So that matrix, the multiplicative inverse, you must be wondering by now where it came from. Well, there's a number of ways to do it. The process that you follow by hand is you take your matrix A and you put it into a bigger matrix with the corresponding identity matrix right next to it. And then we use our row operations to change it so on the left-hand side we have I, and what remains in the other side will be the inverse. That's what we're going to do first. But of course, we can always use our calculator and also WinMat to do exactly the same thing. So I'm going to start out by finding the inverse matrix of A equals, in the first row, 1/2, 3, and in the second row, 1 and 5. So the first thing I do is I take the matrix A and the corresponding matrix I. So if A is a 2 by 2, I is also the 2 by 2 identity matrix, and I put them into a bigger matrix next to each other. So when I take these two 2 by 2s and put them next to each other, I get a 2 by 4. Now what I'm going to go do is I'm going to go through a bunch of steps so that I end up with the identity matrix on the left, and whatever is on the right, that's our inverse matrix. So let's go through that process. So here I see my matrix A on the left-hand side of this 2 by 4, I on the right-hand side, and I'm going to follow what is pretty much Gauss-Jordan for putting a 1 in the first row, second row, zeros below, and then a 1 in the second row, second column, and then zeros above. So to start out, I'm going to interchange row 1 and row 2 so that I can put that 1 that I see in the second row, first column into the first row, second column. So when I interchange my two rows, now I have 1, 5, 0, 1 in the first row, now 1/2, 3, 1, 0 in the second row. Now that I've got the 1 where I want it, I need that 1/2 to become a 0. So I'll take negative 1/2 times row 1 plus row 2 and put the result in row 2. So negative 1/2 times 1 plus a half puts a 0 down there, just like I needed. Negative 1/2 times 5 is negative 2.5 plus 3 gives me a half. Negative a half times 0 plus 1 is 1. Negative a half times 1 is negative a half plus 0 gives me negative a half. So now I've got the 1 and the 0 like I wanted. Next I need that 1/2 in the second row, second column. I need that to become a 1. So I'm going to take 2 times row 2 and put the result in row 2. So when I do that, the second row now becomes 0, 1, 2, and negative 1. And notice that the first row doesn't change at all. Now I need to use the 1 that I just created and put zeros above that. So to do that, I'm going to take negative 5 times row 2 plus row 1 and put the result in row 1. So negative 5 times 0 plus 1 will be 1. Negative 5 times 1 will become negative 5 plus 5 gives me the 0 that I needed. Now if I continue, negative 5 times 2 is negative 10, added to 0 gives me the negative 10, and negative 5 times negative 1 is 5, plus 1 gives me 6. So I've gone ahead and made the left-hand side of this matrix I, so that means that my inverse is on the other side. So that the inverse matrix is in the first row, negative 10, 6, and in the second row, 2, negative 1. And that's the process that we generally follow. If we start with a larger matrix on the left, like a 3 by 3, then we start with a 3 by 3 inverse matrix on the right, and then I go through the process of getting 1s and 0s like we did with Gauss-Jordan, so we eventually end up with the 3 by 3i on the left-hand side, and then the inverse is on the right-hand side. So let's go ahead and check to make sure this actually works. So let's take A times the inverse matrix A minus 1 that we just found. So we're going to multiply A, which is 1/2 3, 1 and 5, times the inverse, which had in the first row negative 10, 6, and 2, negative 1. So when I work out my rows and columns, so first row times first column will be 1/2 times negative 10 plus 3 times 2. Second row times first column is 1 times negative 10 plus 5 times 2. First row times second column is 1/2 times 6 plus 3 times negative 1. And second row times second column is 1 times 6 plus 5 times negative 1. If I go ahead and simplify, I'll see that I do get out the 2 by 2 identity matrix as I'm supposed to. And if I were to switch it around, it would work perfectly well. If I took the inverse times A, I would also get what I needed, the I matrix.